In this example, we will convert the function 1 over 1 minus x into a series and find its interval of convergence. Remember that if we have 1 over 1 minus x, that is sum of x to the n, where n is 0 to infinity. This is one of our favorites that we'll just have to remember. What's the difference between these two? Here I have x, here I have x cubed. So what I'm going to do is I'm going to replace x by x cubed. So if I replace x by x cubed, then this becomes x cubed, and replacing x by x cubed means that I have x cubed to the n. But x cubed to the n is x to the 3n. So this is our series. How we will find the interval of convergence, the easiest way is just to point out that over here we needed absolute value of x to be less than 1 in order for this to converge. We've replaced x by x cubed, so instead what we need is we need absolute value of x cubed to be less than 1 in order for it to converge. Because the only difference between these things is that instead of x I have x cubed. So we'll do exactly the same thing with the interval of convergence. Maybe let me put this one up here. This one converges for absolute value of x less than 1. So this one will converge for absolute value of x cubed less than 1. We've just replaced x by x cubed. Well, if I take the cube root of both sides, I get absolute value of x. Well, there's some technical issues that are going on here. The absolute value of x cubed is actually just x cubed, because if x is negative, x cubed is negative, and so on and so on. Well, let me say this precisely. What we really do is we're taking negative 1 less than x cubed less than 1. That's what we're looking at. Because if I say something in absolute value is less than 1, I can put it on opposite sides with the negative. Now I'm going to take the cube root. Cube root of negative 1 is negative 1. Cube root of 1 is 1. So we still get to the same final result, but we have to be careful about how we get there. This will be our interval of convergence for the given series.